It's absolutely unsound. It's going to detonate. No, giving me won't be an astonishing opportunity to go for that. The thing is, it very well may be tomorrow, it very well may be during this transmission. What's more, it would gleam like a second sun. Over the James Webb Telescope, as of late, it has detected an astonishing 250% increase in the brightness of the dreadful Betelgeuse, the red star found at the shoulder of the Orion constellation. This capricious behavior has ignited excitement for a captivating feature. Some suggest the unforeseen increase in brightness could indicate that Betelgeuse is preparing to go supernova. Yet, the particular timing remains questionable. Specialists estimate it could happen before long. Join us as we explore the depths of space and unravel the secrets surrounding this heavenly giant. Betelgeuse can potentially reshape how we understand the universe. Regardless of its name not being well known, you've probably noticed its splendor, a dazzling, rosy shine emitting from the shoulder of Orion, a noticeable star group. Betelgeuse's size is staggering. If set at the center of our solar system, its outer surface would extend past Jupiter's orbit. This massive star, easily visible, continues to captivate us. Unlike most stars, Betelgeuse varies in brightness over time because of its proximity to our system. Known as a semi-regular variable star, its brightness changes occasionally, indicating a potential catastrophic breakdown in a cosmic explosion. As of late, Betelgeuse has become significantly more dazzling due to dramatic changes in brightness. These changes include a significant surge on May 20, 2023, when researchers noted a staggering 142% increase in brightness, followed by a later update showing a 150% increase. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, notes that Betelgeuse currently ranks as the 7th brightest star in the night sky, climbing 3 spots from its usual 10th position. From the southern hemisphere, Betelgeuse shines brightly in the evening sky, easily visible at the shoulder of the Orion constellation. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, underlines Betelgeuse's significance. It offers a captivating opportunity to study the final stage of a massive star's life, providing critical insights into the behavior of red giants before they detonate as supernovae. When Betelgeuse eventually explodes, it could become incredibly bright for about 7 days, possibly creating shadows at night. This prospect has both amateur stargazers and expert astronomers eagerly anticipating the event. Heidi Morris, a researcher at Los Alamos National Laboratory and president of the Pedro Space Scientists and Cosmology Club, highlights the enduring interest in Betelgeuse's brightness changes, a phenomenon long overlooked by other cultures. Currently, Betelgeuse's brightness cycle lasts about 130 days, much shorter than its usual 400-day cycle. These rapid changes offer astronomers a unique opportunity to study this celestial phenomenon in detail, uncovering more about the last stages of a star's life. The strange behavior of Betelgeuse began in 2019 when it violently ejected part of its outer atmosphere. These changes in brightness are exceptional for Betelgeuse, igniting speculation about whether it will soon explode into a supernova. According to a paper by Dupree and other researchers from Harvard and University of California, Berkeley, it will take another 5 to 10 years before Betelgeuse returns to its normal 400-day brightness cycle, as its light and outward velocity behavior have changed. Despite its erratic behavior, Betelgeuse remains a massive red supergiant star, going through the final stages of rapid evolution. As it drains its fuel, the core will eventually collapse under its immense mass, resulting in a colossal explosion that could potentially darken entire galaxies. The timing of this explosion remains uncertain. As explained by Dr. Doc, a professor of astronomy at the University of Portsmouth, predicting astronomical explosion events is challenging due to the limited historical data and the complexity of stellar evolution. Betelgeuse is currently undergoing fusion processes, constantly evolving through elements like helium, carbon, oxygen, silicon, and iron. As a red giant star, it fuses helium into carbon at its core, a process that takes millions of years. Ultimately, it will progress to fuse heavier elements until it can no longer sustain fusion reactions, leading to gravitational collapse and possibly forming a black hole or neutron star. While some hypothesize about Betelgeuse's looming explosion, historical records show that it has been growing red over the past few years, suggesting that it may take considerable time before it goes supernova. NASA estimates that Betelgeuse isn't expected to explode for another 100,000 years, offering comfort that its blast is unlikely to happen within our lifetimes. Despite the uncertainties in Betelgeuse's behavior, Its changes continue to captivate researchers and inspire advances in our understanding of stellar evolution. Dr. Sarah Webb reminds us to stay open to all possibilities, even as we acknowledge that the probability of seeing Betelgeuse's explosion in our lifetimes is slim. Tracking its changes may lead to further scientific breakthroughs, allowing us to keep hope alive for new discoveries in the universe. It is significant to remember that our observations of Betelgeuse. Incredibly, this brightness would be visible during the daytime, creating dramatic shadows at night. Estimates suggest that Betelgeuse could become 15 to 100 times brighter than Venus, currently the second brightest object in the evening sky. The display of Betelgeuse's explosion would last for at least 100 days, captivating space enthusiasts and offering a unique opportunity to observe the aftermath up close. Fortunately, Betelgeuse's supernova would pose no threat to humanity, as it is still far away. Telescopes and optical instruments would allow us to observe the event without harm. Nevertheless, such a spectacular event would not go unnoticed. Supernovae are often interpreted as ominous signs, and Betelgeuse's demise could provoke intriguing reactions. Overall, astronomers believe it could indeed reignite widespread interest in stargazing, awakening people to the wonders of the universe. Betelgeuse does not appear to be the only red supergiant in our galaxy. Others, like Eta Carinae, could explode before it does. In fact, our Milky Way should experience a supernova about once every 30 years, but we haven't seen one in the last 400 years. However, we've observed the remnants of past explosions, indicating that we're overdue for a significant celestial event. It's only a matter of time before the next star goes supernova and the universe takes notice. Betelgeuse's history is rich with notable events, including the dramatic dimming in the fall of 2019. This sudden drop in brightness baffled astronomers and sparked speculation about its potential explosion. Although Betelgeuse's brightness returned to normal by April 2020, the cause of its dimming remained a mystery until further observations provided insights into the phenomenon. Skywatchers can easily spot Betelgeuse from their homes, making it an accessible astronomical object to engage with. If a supernova occurs, it would undoubtedly provide an incredible celestial display. As we continue to monitor Betelgeuse, the star remains a focal point of interest for both professional astronomers and amateur skywatchers alike. The ongoing changes in its brightness offer fascinating opportunities to study the cycles occurring within a dying star. With advanced technology, researchers can now examine Betelgeuse's behavior with unprecedented precision. Instruments like the James Webb Space Telescope, alongside ground-based observatories, are uncovering more secrets about this celestial giant. The study of supernovae, like the one Betelgeuse may ultimately become, has far-reaching implications beyond understanding the final stages of a star's life. These explosions play a critical role in the formation of elements heavier than iron, which are essential for the creation of planets, life, and the very universe we live in. In many ways, the death of stars like Betelgeuse contributes to the building blocks of the universe, enabling new stars and planets to form from the remnants of their exploded cores. Should Betelgeuse go supernova during our lifetime, it would offer an exceptional and breathtaking opportunity to witness such an event up close. For those lucky enough to observe it, it would be a once-in-a-lifetime spectacle. The light from the explosion would temporarily surpass all other stars, becoming a prominent feature in our sky. As space experts rush to capture the data, the event would fuel further advancements in space exploration, enabling more research into stellar evolution, cosmic explosions, and the mysteries of the universe. Regardless of when it occurs, Betelgeuse's potential explosion will be a critical event for astronomy, expanding our understanding of star death and the life cycles of massive stars. The spectacle may also inspire future generations of astronomers, sparking an interest in the universe and encouraging people to look up in awe at the vast cosmos. As researchers continue to observe Betelgeuse's behavior, the mysteries surrounding its life cycle and impending explosion continue to spark interest across the scientific community. One of the most captivating aspects of this star is its volatility. While many stars display regular patterns of brightness, Betelgeuse is anything but typical. The changes in its light output are not merely due to its normal fluctuation, but also the violent activity occurring in its outer layers. These eruptions, which expel material from the star's surface, are a sign of its instability and add an additional layer of interest to its potential for becoming a supernova. Betelgeuse's behavior is not only fascinating for astronomers, but also for scientists working in other fields. The star's irregular activity provides valuable insights into the complex dynamics of stellar evolution. By studying such a massive and unstable star, researchers can learn more about the processes that govern the end stages of a star's life. This knowledge could help inform theories about the life cycles of other stars and the ultimate fate of our own sun. The information we gather from observing Betelgeuse can be applied to broader questions about how stars interact with their environments and how these interactions contribute to the shaping of galaxies. Additionally, understanding the death of stars like Betelgeuse could help us comprehend the larger-scale processes that influence the evolution of the universe. Supernovae, the explosive end of a massive star's life, are responsible for dispersing elements into space, which in turn create new generations of stars and planets. These stellar remnants can become crucial components of future systems that might eventually harbor life, just as our own planet is formed from the remnants of previous stellar explosions. The explosion of Betelgeuse, whenever it occurs, could offer researchers a rare opportunity to study this process in real time, revealing the complexities of how elements are synthesized and distributed throughout the cosmos. Betelgeuse also offers an opportunity for international collaboration in astronomy. Different observatories and space agencies around the world are keen to observe the star's behavior in various wavelengths of light, from visible to infrared and X-rays. By combining data from telescopes such as the Hubble Space Telescope, the James Webb Space Telescope, and ground-based observatories, scientists can gain a more complete understanding of Betelgeuse's evolution. This global collaboration enhances the accuracy of predictions about the star's future behavior and helps scientists refine their models of stellar life cycles. The interest in Betelgeuse has even inspired more public engagement with space science. As amateur astronomers track its fluctuations in brightness and share their observations, a sense of excitement is building around the star's potential to go supernova. Many people who are not professional scientists are actively contributing to the study of Betelgeuse, which helps foster a greater public appreciation for the universe. This increased interest in stargazing and space exploration could inspire future generations to pursue careers in science and technology, further advancing our understanding of the cosmos.